Hello students, today again we solve some numerical problems. Here there is one problem that a particle performing linear S.H.M. of period twice per second about the mean position O, and it is observed to have a speed of b under 3 meters per second when it is at distance b from O. Now from this data we write here t is equal to twice pi second. Therefore, we get omega is equal to twice pi upon t. Means twice pi upon omega, or twice pi upon twice pi. It is 1 radian per second. Now, v is given b under root 3 meter per second. X is given, it is equal to b. If we draw here a path of S.H.M., say O, and right and left extremity shown by M and N, here there is point P which is situated at distance B. Velocity is b under root 3. This is given. Now from this we calculate the amplitude of S.H.M. So here amplitude can be calculated by knowing the value of V, S and omega. So here V is equal to omega under root a square minus x square. V is equal to b under root 3. Omega is 1 under root a square minus b square. So squaring on both sides, here we get 3b square is equal to a square minus b square. Therefore, a square is equal to 4b square, and a can be twice plus or minus twice b. Amplitude we know. Now, in the first stage of the calculation, we calculate the time required to travel. Time to travel x is equal to b. It can be x is equal to a sin omega t1. Suppose that time we denote by t1. X is equal to b. A we have calculated as twice b. Sin omega t1. We get here sin omega t1 is equal to b upon twice b. Means omega here sin omega t1 is equal to half. Therefore, we directly write omega t1 is equal to pi by 6 radian, and from this we get t1 is equal to pi by 6 divided by omega. T1 is equal to pi by 6 because omega is equal to 1. That we have calculated, 1 radian per second. So this is the time, which is the time required to travel from the distance x is equal to b from the mean position. It is time required from O to P. Suppose. Now we read the next part of the problem. If the particle is moving away from the O at that instant, find the time required by a particle to travel further distance b. So we have to understand this point. Here, time required to travel from O to P we have calculated P1. Now, suppose we assume the particle again traveling from O to M. The time required is here in the second step, time to travel x is equal to b plus b, means O to M. It is equal to, suppose t2, and we directly take it as t by 4 because Here the displacement from mean position is twice b, that means the amplitude, and here it is asked to travel further distance b, means b to b plus b, means twice b. The time required from O to M is T2 suppose, and it is T by 4. T by 4 can be equal to twice pi upon 4 is given is pi by 2 seconds. In the third step, we write the answer. Here, time required from O to M is T2. This time required is T2. And O to P is T1. Therefore, from P to M, the time required is T2 minus T1. It is equal to pi by 2 minus pi by 6. It is equal to pi by 3 seconds. This is the answer. So you have to write the problem step by step, solve the problem step by step by understanding the meaning of to travel further distance of b. Here initially it is given that particle is travelled from x is equal to b, and again further it has to travel b plus b, means here amplitude is twice b, so it must reach from b to m, and that time interval is t2 minus t1. The next problem we discuss is given the displacement of an oscillating particle is given by x is equal to a sin omega t plus b cos omega t. This is given. Suppose this is equation 1, where a, b and omega are constant, and we have to prove that the particle performs linear S.H.M. of amplitude a is equal to under root a square plus b square. Here the given equation we are observing it is the composition or combination of two S.H.M.s. So first S.H.M. in this case is x1 is equal to a sin omega t, both equation 2, and the second displacement is b cos omega t. B cos omega t can be written as here b sin pi by 2 plus omega t. So this is equation number 3. So we have given the combination of two S.H.M. One is x1 is equal to a sin omega t, and second one x2 is equal to b sin pi by 2 plus omega t. So here from the observation, phase difference between them is pi by 2 plus omega t minus omega t, it is equal to pi by 2 radian. Amplitude of first is a1 is equal to a. For the second it is a2 is equal to b. So from this we can calculate for resultant amplitude. Resultant amplitude is given by a is equal to a1 square plus a2 square plus twice a1 a2 cos phi 1 minus phi 2. This is the expression for resultant amplitude. Easily substitute here a1 is equal to small a and a2 is equal to b. So a square b square plus twice a into b into cos of pi by 2 radian. Here a is equal to a square plus b square plus twice ab into 0, cos 90 is 0, cos pi by 2 is 0. So we get the resultant amplitude as the square root of a square plus b square. The next problem is find the number of oscillations performed per minute by a magnet. It is vibrating in plane of uniform magnetic field of induction 1.6 into 10 to minus 5 Weber per meter square. So B is given 1.6 into 10 raised to minus 5 Weber per meter square. In this magnetic field, the magnet is vibrating. The vibrating magnet can be shown like this. It is vibrating in this arc of a circle. Now, moment of inertia I is given. It is 3 into 10 raised to minus 6 kilogram meter square. Magnetic moment, it is denoted by mu, is given 3 ampere meter square, and we have to calculate number of oscillations. So here we have to calculate the frequency, but we calculate first the period. Period is equal to twice pi under root I upon mu b. This relation we have derived. So we write twice pi under root I is equal to 3 into 10 raised to minus 6 divided by 3 magnetic moment, and B is 1.6 into 10 raised to minus 5. We get C is equal to twice pi inside the square root. Here C is cancelled and we get 1 upon 16 by adjustment. So we get T is equal to twice pi upon 4. Means T is equal to pi by 2 seconds. Therefore, we get N is equal to 1 upon T, N is equal to 2 upon pi third. Now, the question is number of oscillations performed in 1 minute. Therefore, we write here number of oscillations in 1 minute can be equal to N into 60. So here 2 upon pi into 60. Here we have to substitute for pi is 3.142 into 60, and the answer is 38.919 oscillations per minute. So this is the answer. Simple problem is there. We have to substitute for period. Period is calculated, then frequency. It is the number of oscillations per second. In 1 minute, we can calculate it by multiplying with 60 seconds, and then we get the final answer. So this is about the problem. So you have to solve problems as well as problems given in the exercise. So we have covered some problems in the exercise. Also, you try to solve the multiple choice questions. If any difficulty, you can ask in comment box. Thank you.